Welcome to the Fuel Pulse Show podcast, where we talk about all things fuel for all kinds of people. Here at the Fuel Pulse Show podcast, we talk about issues and the matters of interest on all the different kinds of fuels that you use at work and at home, along with talking about all the things that use that fuel both at work and at home. And that means that the Fuel Pulse Show podcast is for everyone. I'm your host, Erik Bjornstad, and I like to call myself your guide through that ever-changing world of fuel. So, what are we going to talk about today? Well, it is that time of year, again, when the meteorologists issue their predictions for the upcoming Atlantic hurricane season, as well as updating any predictions that they may have made earlier in the year. Now, as June the 1st approaches, marking the official start of the Atlantic hurricane season, communities along the different coasts that are affected by hurricanes, the Gulf Coast and the Atlantic Coast, and all along Florida, they are gearing up for what is forecasted to be an extraordinarily active season for 2024. And predictions from a number of the most authoritative meteorological agencies are setting the stage for us having a hurricane season that could surpass previous records in both the frequency or number of hurricanes, but also their intensity. So experts from Colorado State University, sometimes abbreviated CSU, and the National Oceanic and Atmospheric Administration, also known as NOAA, as well as some other international weather organizations, they are anticipating, as they put it, an extremely active hurricane season. And Colorado State's forecast is particularly striking. They are predicting 23 named storms, and we'll talk about what a named storm is a little bit later. 23 named storms, 11 hurricanes, 5 major hurricanes. And they also said that they are anticipating an accumulated cyclone energy, or ACE, ACE index of 210 units. And so we'll talk about what that means as well. So let's just say from the start that all those figures, 23 named storms, 11 hurricanes, 5 major hurricanes, all those figures are among the highest. If they all come true, if it comes to pass, they will be among the highest figures that we have seen in the last 100 years. But let's delve a little bit more into the details here, because projected number of named storms and hurricanes, that's easy to understand. When somebody predicts we're going to have 11 hurricanes, sure, people understand what they're talking about. But what about this thing they call the ACE index? What is the ACE index, you ask? Well, I'm glad you asked that, right? You did ask that, didn't you? Yeah, I thought that was you. So the ACE index, again, accumulated cyclone energy. The ACE index is a measure used by meteorologists to express the total strength of a storm. So when CSU says we're going to have 210 ACE units over the course of the season, they're talking about all the storms they're predicting and how strong they are added up, right? So the ACE index is an expression of the total strength of a storm. You could also say it's an expression of the energy used by a tropical cyclone over its lifetime. And this metric, this ACE index, helps meteorologists and climate scientists gauge not just the number of storms in a season, but also the strength of those storms and how long those storms lasted. And is particularly useful for comparing the overall energy and the potential destructiveness of tropical cyclones over different seasons or regions. So it's kind of a useful tool that meteorologists have developed. Now, a higher ACE value over the course of a hurricane season, if you're talking about not just one storm, but a period of time, a higher ACE value over the course of a hurricane season indicates a number of things, right? It could indicate more, in fact, I should say it probably indicates more frequent storms, a greater number of storms, but also can hint at more intense or more powerful hurricanes in that season. And it's also useful to use to look at over time, because if you can look at the trend of ACE figures, ACE index figures, if you can look at those figures over longer periods of time, it can help us to understand other things like climate trends, especially in the context of climate change. For example, if you took several decades and you looked at the hurricane seasons over multiple decades, so a larger period of time, and you looked at the ACE values year by year over those multiple decades, one thing you might be able to tell from that is that hurricanes are becoming more intense, which might then lead you to look at other things to try and explain that, like, let's say, ocean temperatures. Okay, so that's the usefulness of the ACE index. How do they calculate it? Well, the math can sound a little bit complicated if you were to try and explain each and every step, so we don't really need to do that here. But in short, what you do is the starting point for consideration is when the storm is first classified as a tropical storm. And that happens when the maximum sustained wind speed exceeds 40 miles per hour. Now, one thing to note here, we said maximum sustained wind speed. That's not the same as the maximum speed, or asking what's the hardest wind gust. Maximum sustained wind speed is measured the same way by everybody, so that everybody at every location in the world knows what it means. What they're doing is they measure the wind speed at a point above the ground, so not even at ground level, but at 33 feet above the ground. And they're looking for the average wind speed over a 1 minute period of time. That is the maximum sustained wind speed. Again, different from just maximum speed. So once the storm reaches tropical storm status, now they're going to start taking wind speed measurements every 6 hours, and they're going to measure them in knots. Just in case you're not familiar with nautical measurements like that, if you hear that a wind speed is 35 knots, that's about 40 miles an hour. If you hear 85 knots, that's about 100 miles an hour. So it tracks it relatively closely. So they keep taking measurements every 6 hours, and they do this until the storm weakens enough that it loses its tropical storm status. Then they take all the numbers that they measured, they square them, they add them up, and then they divide by 10,000. And the only reason they divide by 10,000 is to give them a manageable number to work with, right? Because somehow it's easier for people to comprehend when you say, oh yeah, the ACE index was 210. It's easier for them to understand the significance of that than if you were to say, oh yeah, the ACE index was 2,110,000, even if those might be referring to the same thing, right? So there you have the ACE index. Because it looks at maximum sustained wind speed over the life of the storm, it's a meaningful expression of a storm's sustained power and energy over the course of its life. So think of it not as what's the maximum power of the storm. It's actually more like what's the total power of the storm. So, for example, let's say that you have a tropical storm, and the tropical storm ended up lasting for 18 hours, which isn't really that long. So we're not talking about a serious one, right? So an 18-hour tropical storm. And so over the course of those 18 hours, they're going to get 3 wind speed measurements. And let's say that those wind speed measurements were 40, 50, and 60 knots, which is like saying it's 50, 60, and 70 miles an hour, though not in order. Okay. What's the ACE index for that situation? That for that relatively small tropical storm, the ACE index would come out at about 0.77 ACE units, as they call it. So what Colorado State University gave us in their prediction for the upcoming 2024 hurricane season was a total ACE index, what they think the total ACE index is going to be for the entire hurricane season from June 1st up through the end of November, when it traditionally ends. And that is something that's figured up every year, adding up all the ACE scores for all the named storms that season. So Colorado State is predicting the 2024 hurricane season to have an ACE score of, in total, of 210. Now, if you couldn't guess already, that's unusually high. In fact, since the year 1900, so 124 years ago, we've only had 7 years where the ACE score ended up topping 200. So Colorado State is predicting that the 2024 Atlantic hurricane season, by all accounts, is probably going to be one of the top 10 worst seasons in the last 120 years. Now, if you go back and look at the ACE score historically, some of those other worst years, when you look at what happened in those years, they make sense. The worst years have tended to be marked by some of the most memorable storms. 2017, you had the Category 5 hurricanes Maria and Irma. 1995, another bad year, had Hurricane Opal. Go back even further, 1926, the Great Miami Hurricane, which, among other things, directly led to the collapse of the Florida real estate market in the late 1920s. That was a bad year. And both 2004 and then 2005, with all those storms that we had, including Hurricane Katrina and Hurricane Ivan. But none of those are actually the most powerful storm year on record. That was 1933, where the worst storm didn't strike Florida or the Gulf Coast. It actually struck way up in the Chesapeake, Potomac area of Virginia and Maryland. And it was a storm that was so powerful, it ended up physically separating Ocean City, Maryland from its surrounding islands, and it created the existing harbor and the existing inlet to the Atlantic Ocean that are still there today. So that was 1933, the most powerful storm year on record. So we're already saying, according to Colorado State, that this ACE index prediction seems pretty high in the context of history. And Colorado State's prediction also seems like a lot. If we were we move away from talking about ACE index and just look at the number of storms that they're predicting. CSU is predicting 23 named storms, 11 hurricanes, and 5 major hurricanes. How do those figures look compared to years past? If you just look at recent history and you look at the 30 years from, say, 1991 to 2020, over that 30-year period, an Atlantic hurricane season produces on average about 14 named storms. And by named storms, we're talking about tropical storms. You start with a tropical depression, and then it strengthens into a tropical storm once the sustained wind speed tops 40 miles an hour. And that is when that becomes a named storm. And so that's what we're talking about here. So the average hurricane season in recent history, you had 14 named storms, you had 7 hurricanes, and 3 major hurricanes, based on the average of years from 91 through 2020. Now, we also noticed, looking back through history, that those numbers for the number of storms have increased steadily over the decades. Now, you can look at the numbers and compare the numbers from the 1980s, the 1990s, the 2000s, the 2010s, and then this first part of the 2020s. And when you do that, you see a big difference there. So in the 1980s, 1980 to 1989, those 10 years, there was an average of 9 named storms. You already know that we're starting at a low number. 9 named storms, 5 hurricanes, 1.5 major hurricanes a year. Going to the 1990s, those numbers are starting to bump up a little bit. You're going from 9 to now 11 named storms, going from 5 up to 6 hurricanes, and you're going from 1.5 to now 2.5 major hurricanes on average, going from the 80s to the 90s. And then things just keep increasing from there. Go to the 2000s, now you're averaging 15 named storms. You went from 11 to 15. You're averaging 7 hurricanes and 3.6 major hurricanes. And then the 2010s, we're actually pretty close to those numbers. And then for the last 4 years that we have data for, that's 2020 through 2023, we have been topping 21 named storms a year, 9 hurricanes, and 4 major hurricanes. Notice the difference in those numbers changing over the decades from the 80s, 90s, 2000s, 2010s, 2020s. Named storms 9 to 11 to 15 to 21. Hurricanes 5 to 6 to 7 to 9. And then major hurricanes, and a major hurricane, I believe, is at least a category 3. 1.5 to 2.5 to 3.6 to 4. So basically, if you look at the 2020s, the last 4 years, they've been averaging fully twice the activity that the 1980s had, 2 times the activity of the 1980s. I mean, the most activity that you had in any year of the 1980s was 1984, when you had 13 named storms. We're now working on a string of 10 straight years where we've had more named storms than the busiest year of the entire decade of the 1980s. 10 straight years. I could be mistaken, but it seems like the bad weather is getting worse, right? So, why are things this way? Why do we seem to be having more storms? Well, people commonly cite climate change, right? And I'm not necessarily saying that those people are wrong. There are recent studies that have begun to shed some light trying to ask that question, and they're starting to shed some light on some things that are happening in the global economy that might be related to that trend, that increasing trend. So major storms are a function of the conditions of the climate. And beyond this simple, undeniable fact that we are consistently having more major storms in recent years than we have had in the past, there are also some additional, what I would call, weird facts that kind of also point in that direction to where we could be forgiven thinking that something is happening with climate change and that whatever is happening with climate change might have something to do with this. So the first thing that we have noticed, and these things that I'm going to talk about are not really, I don't want to sound like somebody who says you can't argue about this, but these are not matters of opinion. These are observed facts in the meteorological data. Okay, so the first thing that we notice is has to do with rapid intensification increase. Over the last 10 years, so that's really from, let's say, 2023 back through 2013 or 2014. Over the past decade, there's been a noticeable increase and significant increase in the number of storms we've had that have undergone this rapid intensification phenomenon. And what we're talking about there, it's a phenomenon where the maximum sustained wind speeds of a tropical cyclone or a storm increase by at least 35 miles an hour within a short period of time, within a 24-hour period. That is the meteorological definition for rapid intensification of a storm. And historically, for that to happen has been a fairly rare thing, but it's happening much more often in the recent past than it ever has before. Now, why is that? Is it because the stock market's up? Is it because Pat Mahomes is quarterback of the Chiefs? No, of course not. The research suggests that warmer sea surface temperatures, which happen to be an accepted consequence of climate change, are likely contributing to that intensification trend. And if you want a recent example of one affecting the other, you only have to go back to 2018, Hurricane Michael. Once Hurricane Michael hit the warmer water in the Gulf of Mexico, water that is known by everybody to be warm. So once a storm passes Cuba and those islands in the Caribbean, and it hits the Gulf of Mexico, everybody knows that water tends to be warmer, so they expect storms to intensify. But what has been seen, though, is that the water hasn't just been warm, it's been historically or unusually warm, even by hurricane season standards. Once that Hurricane Michael hit the Gulf of Mexico with that unusually warm water, it went from a Category 1 storm to a Category 5 storm in just 2 days. That is a really unusual chain of events. And that kind of thing can be directly linked to the unusually warm waters in the Gulf that are a result of climate change, or so they say. Second thing that we notice is there's an expansion of the tropics. Now, what do we mean by that? We got this fact that the planet's tropical weather belt has been observed to be gradually widening, getting bigger, due to shifts in atmospheric circulation patterns, which they say are influenced in large part by global warming, or so they say. Now, this tropical belt, what are we talking about? When we talk about a tropical belt, it's the region around the globe, around the Earth, that is situated near the equator, and it happens to be characterized by tropical climate conditions. And it's normally that band between the Tropic of Cancer in the north and the Tropic of Capricorn in the south. Of course, that then means it also includes that equatorial zone in the middle. And that all that is the zone of the Earth where the climate is typically hot and humid, and therefore it's the area where the most tropical cyclones form. Now, over recent decades, meteorologists have observed that this tropical belt's actually widening. It's expanding outward in both the northerly and southerly directions. It's creeping further north, it's creeping further south. It's getting bigger and wider. That means there are now more places on Earth that are experiencing tropical warm weather and high humidity, which means we're getting more major storms forming, and that is due, they say, to global warming and climate change, or so they say, right? And meteorologists have also noticed, and this is interesting, they've also noticed that this expansion of the tropical belt we're talking about has altered the Earth's jet streams. So if you change the jet stream, right, that will give you more unusual storm tracks. And it will also cause or lead to the appearance of more storms in regions that aren't typically prone to severe weather. Now, if anybody remembers Superstorm Sandy in 2012, rampaging not through the Gulf Coast, rampaging through New York and New Jersey. Superstorm Sandy is an example of what they're talking about. It's a kind of storm in a place that you don't normally see, except climate change made conditions much easier for it to form and show up in unusual places, or so they say. Now, we understand that there are plenty of people who will passionately dispute the significance or the existence of climate change, and we're not really here on today's episode to wade full bore into that debate. We understand that everybody's got an opinion, and if you disagree with any or all of these things, let's just leave it by saying that all of these things that we just said are really just things to think about. There's things that are being observed. The significance or the cause of those things, I'm sure we can debate and discuss. But those are the things that are being observed right now on the planet. Now, how do hurricanes form, right? If you really want to understand why there's this 2024 hurricane predictions, why they are the way they are, it helps if you know a little more about what makes hurricanes and storms form. Now, to form a hurricane, or for a hurricane or a tropical storm to form, you have to have several essential elements. You have to have them, and they have to come together to create the right conditions for that storm to develop and that storm to grow. Okay, we're going to talk about what those things are so we understand this a little bit better. Okay, number one, first thing you need, warm sea surface temperatures. Hurricanes require warm ocean water to form. How warm? Typically, the temperature needs to be at least 80 degrees Fahrenheit, or for our metric friends, 26.5 degrees centigrade, or higher. And this warm water is what provides the energy and the moisture needed for the hurricane or the storm to form. Warm water is the fuel for the storm. Now, every weather authority that you talk to will tell you the seas are getting warmer right now. And they'll also tell you that the year 2024 is going to have not just warm sea surface temperatures, it's going to have record warm sea surface temperatures. Hence, more storms. Okay, second thing, hurricanes and storms need atmospheric instability. Okay, so what you have is you get warm air rising from the ocean surface. When that air rises, what has to happen is it has to encounter unstable conditions in the atmosphere that actually promote further lifting of that air. And as it continues to rise, as that warm, moist air rises, what's going to happen to it? It's going to cool, and it's going to condense, and it's going to form clouds, and it's going to form precipitation. But that process of that previously warm air cooling, it's going to release what they would call that air's latent heat. Because remember, law of thermodynamics, heat being energy, energy is not created or destroyed. It just changes forms. It moves elsewhere. That heat is going to get released from the air as it cools. And what that heat is actually going to then be there when the further air that's following the warm air, the air that's coming up underneath it, it's going to come up and it's going to get warmed by that latent heat that was released by the air above it cooling down. And so that is then going to cause that air to rise further, reach the other air, join it, rise further, strengthen that cyclone, and repeat this process. So, first thing you need is warm water. Second thing you need is atmospheric instability with warm air rising up from the ocean. That's number 2. Third thing that you need is it really helps to have moisture in the atmosphere. If you have a sufficiently humid atmosphere, then what you're going to get is it's going to be able to maintain those cloud formations that are really the crucial start to that hurricane's development. Where does that moisture come from? Well, that moisture comes from that warm ocean water. So, warm water, atmospheric instability, moisture in the atmosphere. What else do you need? Well, you can have all 3 of these, and yet though that still not be enough for a major form to storm or to strengthen. It means you need a 4th thing. And that 4th thing that you need is you need low wind shear. Now, wind shear is a term you may have heard meteorologists talk about. Wind shear is something that refers to when you have wind and it's moving in a certain direction, right? Wind shear is variation of wind speed or direction over relatively short distances in the atmosphere. When we say speed and direction, we're not just talking about horizontal, we're talking about both directions, vertical and horizontal. Now, having low wind shear, not high, but low wind shear is crucial, because if you have high wind shear, then that can disrupt the organization of the storm. It can actually cause the storm to break apart before it ever really gets the chance to kind of coalesce and form something and then grow and strengthen. High wind shear, and basically high wind shear when you have wind that's changing direction and changing speeds erratically in all different directions. That basically tears apart storms before they get the chance to grow into tropical storms and then reach hurricane strength. Last thing, once you have all 4 of those previous conditions present, you still need something else. There's one more thing that you need in order to get things going, if you will, and that is a pre-existing weather disturbance. So hurricanes or tropical storms typically begin first as pre-existing disturbances in the atmosphere that basically form a focal point or a seed crystal, if you will, a weather seed crystal around which the developing storm can organize. Now, a pre-existing weather disturbance, what do we mean by that? This kind of disturbance, it could be a frontal boundary between a high pressure system and a cold weather system, a frontal boundary. It could be tropical air waves, like areas of low pressure moving westward across the tropical Atlantic Ocean, something like that. Point is, you need something like that to really get things started. Now, when you have all 5 of these factors aligned, you have a weather disturbance supported by warm water, atmospheric instability, moisture in the air, and low, calm wind shear conditions. If you have all those factors aligning, that's when you can get a tropical depression forming, which then gathers strength. and intensifies into a tropical storm and eventually strengthens into a hurricane if the conditions remain favorable. So that is what needs to be present for hurricanes to form. So, why is 2024 projected to be such a busy season? The expected increase in hurricane activity that they're predicting for 2024 can be attributed to several interconnected atmospheric and oceanic conditions that meteorologists see. And as we mention these, you may start to recognize some of the things that we talked about previously. So, the first thing that we mentioned that was needed for major storms to grow and form, remember what that was? Above average sea surface temperatures, warm water in the ocean. So the Atlantic Ocean in recent past and this year has recorded higher than average temperatures, and that's conducive to development and the strengthening of hurricanes. Remember, warm water is the fuel. The Atlantic Ocean is going to have plenty of warm water in 2024. Second thing is, there's also this weather system that's present in the Pacific Ocean, La Niña conditions that are forecasted to develop by the summertime. Having La Niña is kind of like the sister of that other thing that you hear about, El Nino. When you have a La Niña weather system in the Pacific, having that there is known to significantly influence weather patterns around the globe. And it's known, the presence of that system is known to increase hurricane activity in the Atlantic Ocean. How does that happen? How does having a type of weather system in the Pacific mean you're going to get more hurricanes in the Atlantic? Here's how La Niña in the Pacific leads to more Atlantic hurricanes. First of all, it affects wind shear. When you have a La Niña system, the cooler waters in the Pacific lead to a decrease in wind shear in the Atlantic basin. Remember, as we mentioned before, wind shear is that change in speed and direction of winds at different altitudes, right? When you have lower wind shear in the Atlantic, it makes it conducive to hurricane formation and strengthening because it makes it easier for the vertical structure of a hurricane to form and remain intact and to remain well organized while it further gathers strength. And what they have found over the years is that having a La Niña system in the Pacific is associated with low wind shear in the Atlantic. Okay, that's first thing. Second thing has to do with the Atlantic trade winds. The La Niña system typically, if you have that in the Pacific, typically you see stronger Atlantic trade winds. When you have stronger Atlantic trade winds, they contribute to cooling the eastern and central Pacific, first of all, but then on the flip side, they also help to warm the Atlantic waters. And when you have warmer waters in the Atlantic, what does that do? Serves as fuel for hurricanes. Okay, third thing that they are seeing is they're seeing greater atmospheric instability. See, the atmospheric conditions, when you have La Niña in the Pacific, you tend to see more unstable atmospheric conditions in the Atlantic. And when you have more instability, again, not more wind shear, but more atmospheric instability, that's favorable for the development of thunderstorms, which are the building blocks for hurricanes. And then fourth, they're seeing increased moisture. When you have a La Niña system, what that does is it enhances what they call the monsoon trough, or a meteorologist might say enhances the intertropical convergence zone. And this is an area of the atmosphere that happens to be over West Africa. When you have this kind of thing enhanced over West Africa is right next to the Atlantic Ocean, right? And so it ends up creating weather disturbances, atmospheric disturbances, that then move across the Atlantic. And as they're there and as they're moving, they can develop into hurricanes. Remember, we said a major storm has to have a pre-existing weather disturbance to get it started. Well, that is what these waves are. So, because of these four factors, when you have a La Niña, when you have years that see the development of a La Niña system, those often correlate with above average hurricane activity in the Atlantic Ocean. And for the 2024 season, if La Niña conditions persist, or strengthen, this could likely contribute to an increase in both the number of cyclones and the intensity of those storms in the Atlantic Ocean. So we talked about La Niña all this time. But the one that you probably heard about is El Nino. And over the last few years, we've actually had an El Nino Pacific weather pattern. And this ongoing El Nino that we have had over the past couple of years, what they're predicting is they are predicting for that to weaken by the late summer. And if the El Nino weakens, then that reduces the atmospheric conditions that typically disrupt hurricane development, which means atmospheric conditions are more favorable for hurricanes to grow if El Nino weakens. So if they are correct in their prediction and the El Nino does weaken in the way that they're predicting, how is it going to affect the Atlantic hurricane season besides just saying it's going to create favorable conditions? Well, a weakened El Nino will first of all mean reduced wind shear. Remember, we talked about high wind shear keeps storms from forming, but when you have an El Nino that's weak, the wind shear goes down. So when an El Nino weakens, as they're predicting later this year, wind shear levels in the Atlantic often decrease as well, creating, again, more favorable conditions for hurricanes to develop and intensify. Also, in normal years, having an El Nino affects atmospheric stability and moisture. If you have an El Nino in the Pacific, you tend to have more stable and drier atmosphere in the Atlantic, which are not good conditions for hurricane formation. But El Nino is projected to weaken. That's going to mean the Atlantic atmosphere is going to become less stable and more moist, providing those necessary conditions for cyclonic development, as they say. And then sea surface temperatures. Although El Nino, because it's in the Pacific, right, and the Atlantic's over here, although El Nino primarily affects Pacific Ocean temperatures, it does have global impacts in other areas besides just the Pacific Ocean. A weakening El Nino system will oftentimes lead to warmer sea surface temperatures in the Atlantic basin. Why is that? It has to do with the fact that there's less upwelling of cold water in the Pacific when you don't have El Nino. When there's less upwelling of colder water in the Pacific, that actually alters global heat distribution patterns. And that indirectly warms the Atlantic basin. And of course, we've already said sea surface temperatures in the Atlantic hurricane region are going to be historically warm anyway. So this is simply going to compound that problem. And then the fourth and last thing to mention is an El Nino system affects something that meteorologists call the Walker circulation. Okay, the Walker circulation is this large scale. What we mean by large scale, it means it's a really big, it happens over a long distance on the face of the planet. It's a large scale atmospheric circulation pattern. And it typically occurs over the tropical regions of the Pacific Ocean. Again, not the Atlantic, but the Pacific Ocean. So what you get is, you start in the Western Pacific, right? And you get air that's rising up near the warm waters of the Western Pacific. Then what it does, when it reaches high altitude, it moves east across the Pacific till it reaches the Eastern Pacific, like near California, right? And it starts to descend, probably because it's cooled down. It descends down to the water, and then it returns westward back towards Japan or Indonesia near the surface of the ocean. So what you get is a circulation of air from the west to the East Pacific and back again. This really big atmospheric circulation pattern happening over thousands of miles. Now, this Walker circulation is influenced by the sea surface temperatures. And when you have an El Nino weather system can actually disrupt that circulation, maybe weakening it, keeping it from happening as strongly as it might otherwise. And that leads to widespread changes in global weather patterns. When you have a weak El Nino, when the El Nino kind of loosens its grip on weather patterns by getting weaker. When you have a weaker El Nino and you bring in the presence of a La Nina phase at the same time, then that actually makes this Walker circulation stronger, which leads to more intensified weather patterns across the tropics, which means more hurricanes, more major storms. So we have just listed off a whole bunch of conditions that together are forming the rationale for groups like Colorado State University to be predicting a historically active hurricane season for 2024. And they will tell you that they have seen this combination of 2024 conditions. They've seen them in the past. This thing where we've got warm sea temperatures, low wind shear in the Atlantic, high levels of both atmospheric moisture and high atmospheric instability, and presence of either a weakening El Nino or a strengthening La Nina or both. They have seen that combination of things in a number of the past most historically active hurricane seasons. Some of those years we already talked about. 1995, 2005, there's also 2010 and 2020. So many of the most active hurricane seasons from the past had the exact same set of conditions that we are seeing right now in 2024, which suggests 2024 could be a record-breaking year. Now, what we list off those years, what happened in those years? Well, start with 2005. 2005 is frequently cited as kind of a benchmark year for active hurricane seasons. I mean, I was living in Alabama at the time, and I remember seeing just one hurricane after another coming up. And I remember thinking, I'm never going to see this again, because one hurricane would happen and then there'd be just another one. It'd be like, when will this end? So 2005 is frequently cited as kind of like the year to beat all years. And of course, you had the big one, Hurricane Katrina, one of the most devastating hurricanes in U.S. history. Anybody who lived through that time remembers that really well. But Katrina was by no means the only big thing then, as I said. 2005 set the record up to that point with 28 named storms, 15 hurricanes, and 7 major hurricanes that were category 3 or higher. 1995. The 1995 Atlantic hurricane season had 19 named storms and 11 hurricanes, and the big one was Hurricane Opal. And when they look back at meteorological history, 1995 was really the year that started the beginning of the era of high storm activity in the Atlantic that continued at least into the early 2000s and beyond. 2010 had 19 named storms, 12 hurricanes. And 2010 was bad because you had very warm Atlantic sea surface temperatures and you had really low wind shear, both of which are exactly what we're seeing this year in 2024. And then most recently, the year 2020. 2020, you may remember, 2020 actually broke the 2005 record for the most named storms in a hurricane season. They had 30 named storms, 13 hurricanes, and 6 major hurricanes. And the 2020 season was fueled by exceptionally warm sea surface temperatures and low wind shear. Again, conditions that are basically the same thing as what we've got in 2024. So these years, they're referenced because they all share these common characteristics with what they think we're going to be seeing in 2024. And that means they're predicting for us to have a really bad hurricane season. Okay, so you know all about why they're saying what they're saying. So let's shift gears a little bit and let's move back towards more ground level and talk about what to do in response to this information. Given this heightened forecast for 2024, anyone who's in the hurricane prone area becomes really important to prepare well, prepare thoroughly, and also importantly, prepare well in advance of those peak months of August to October when you tend to see the most hurricanes. So If you're in this kind of area, what should you do? Well, first big one at home anyway is emergency response planning. You want to make sure that all the members of your household, certainly, and then at work, if you're in charge of people, all the members of your organization, you need to make sure that they all understand their roles in emergency. Who's going to do what? Who's expected or who's responsible for doing what important thing when a big event like a hurricane strikes? Something that's pretty easy to overlook when things are calm, but you don't want to make that mistake. The hurricanes are coming. Don't make the mistake of thinking that kind of stuff's just going to work itself out. You need an emergency response plan that you regularly review with your team, your family, people in your organization, people in your household, so that everybody knows what they're supposed to do in an emergency. And then another relatively straightforward piece of advice is emergency kits. You want to prepare emergency kits. What should they have in them? Well, you want at least 3 days supply of water and at least 3 days of non-perishable food per person, along with any medications that they need, flashlights, very importantly, batteries, also very important, first aid supplies, and also one that people might not think of, copies of crucial documents in waterproof containers. All those things kind of easy to overlook, but if you think about it, putting together an emergency kit like that is pretty sound advice. So that's your plan for at home on what you want to do. Now, what about professionally? What do you want to do to prepare at work? We know that in our audience, we have a bunch of different people who serve in different capacities in a bunch of different industries. So we try to think of what's the best kind of advice that would apply to the most number of people that would kind of skirt that important middle. So the big thing is check your stored fuel. The best time to make sure that your stored fuel, your stored emergency fuel, best time to make sure that it's going to work is before you actually need it to work. So the start of hurricane season is a month away. The start of peak season is a handful of months away. This is the time. Now is the time to make sure you don't have microbial contamination in your storage tank, that you don't have a pre-existing water problem. Now, if it turns out you do have water and microbes, and it's best to confirm that through some kind of like water and microbial testing, it turns out you do have a problem, now you've got enough time to clear that problem up, to use biocide to kill the microbial contamination, to get that water phase removed, maybe to polish out, filter out the biomass that has formed. You've got time to clear that problem up and make sure that your fuel is in the condition where it's going to power that generator under the load that you need it. So that it doesn't just start up, but it actually runs under the load that you're going to need it if all the power gets knocked out by a major storm. Now is the time to check your stored fuel. 2 days before a major hurricane, when that major hurricane's bearing down on you, that is most certainly not the time that you want to be first looking at this, because you're going to have way too many other things to worry about. And if you have checked your fuel, if you had gotten it squared away, then when all this other stuff starts happening, you're definitely going to be glad that you at least got your fuel part squared away. So, the 2024 Atlantic hurricane season, projected to be one of the most active in history. Maybe it's shaping up to be payback for last year, which seemed to be pretty active. I mean, we had 23 storms in 2023, but yet it still didn't seem so bad, because I don't recall that any major storms made damaging landfall. With these forecasts, the forecasts from places like Colorado State, with them predicting an unprecedented number of intense storms, that means your preparation is going to become more important than ever. By understanding what's being forecast, recognizing the contributing factors out there in the environment that are going to lead to these storms developing, and then taking informed and proactive steps towards being prepared. Individuals and communities and organizations like yours can substantially mitigate whatever impacts of this record-setting hurricane season are going to be. So, the time to prepare is now, before the first storm is even named. And we just want to encourage you to stay vigilant, stay informed, and be ready to act as the season progresses. And so that is going to do it for this episode of the Fuel Pulse Show podcast. As always, we are going to have links and notes in the show notes, the things that we talked about. If you like what you've heard, feel free to subscribe to the podcast at your podcast purveyor or podcast platform of choice. iTunes, Google Podcasts, Stitcher, Amazon, wherever you get your podcasts from. If you haven't done it already, feel free to subscribe. Feel free to leave us a favorable rating, because that also always helps, especially it helps people who don't know about us, helps people to find us, and we do like that. So with that, I'm your host, Erik Bjornstad, your guide through the ever-changing world of fuel, and I will see you next time for another episode of the Fuel Pulse Show podcast.